Hi again, Pre-Calc. Today we're going to look at lesson 7.4, some more identities, and a couple of specialized ones. These are called double angle and half angle identities. So a bunch more identities for you to write down. Again, these are on the back of your circle chart, except I don't know if the half angle ones are, the double angle ones are for sure. But get these in your notebook too, just for some additional practice and being able to refer to them. So here's the double angle identities. In class we may try to prove or verify perhaps the first one of these, but sine of 2 theta, 2 sine theta, cosine theta. Notice the cosine double angle one actually has 3 different formulas that you can use. And one that has both cosine and sine, one that has just cosine, one that has just sine. And then here's the tangent one. Of course, that always has to be the odd duck out a little bit. So take a little bit of time and write these down, and then we'll go over an example of how these are used in the next slide. Alright, so we're given in this case that the sine of x, again x is an angle here, so the sine is 3/4. Terminal side in the first quadrant, we want to try to find the exact value of these things. So I think the first thing I'd always want to do is draw a triangle, and we'll label this angle we're looking at as x. We'll kind of pretend it's a right triangle. So sine is 3/4. Sine is opposite over hypotenuse, like that. So now we just need to figure out what is that other side. So using our Pythagorean theorem a little bit, 4 squared is 16, minus 3 squared is 9, so 16 minus 9 is 7. And so this missing side will be the square root of 7. Because everything is in the first quadrant, we know that things are going to be positive. Values are going to be positive, at least initially here. So sine of 2x, I'm going to change colors here so it's a little bit more vibrant. According to the formula, it is 2 sine x cosine x. And so substituting our values in this case, the sine of x we know already, that's going to be 3/4. And the cosine of x, we just have to look at our triangle and figure that out. Cosine is adjacent over hypotenuse, so that's going to be the square root of 7 over 4. And so if we multiply all this stuff out, we're going to get, keep in mind that 2, you can write that as 2 over 1. So we're going to have 6 times the square root of 7. And all that is going to be over 4 times 4 is 16. And I can reduce that a little bit, so I get 3 times the square root of 7 over 16. Weird number, but that's the value of the sine of 2x. Alright, let's look at the next one here a bit. Cosine of 2x. Now if we recall from the previous slide, the cosine double angle formula has 3 different options here. You can use whichever one seems easiest. And since they give us, in this case, that the sine is 3/4, maybe we should just go ahead and use that one. So the cosine formula for the one that uses sine is 1 minus 2 sine squared x. So in this case, it's going to be 1 minus 2. We already know that the sine is 3/4, but then I do have to square that. So this will end up to be 1 minus, again I have to do the squaring first, that's 9/16. And 2 times 9 is 18/16. And really then what this is going to end up to be, remember I can write 1 here as 16/16. This is going to end up to be negative 2/16. I can reduce that to negative 1/8. Now you might be saying to yourself, whoa, why is this a negative number? Because I thought it said something about being in the first quadrant, and we know that everything is positive in the first quadrant. Well, keep in mind this is a double angle formula, so when we're not just trying to find the cosine of that angle, but double what that angle is. So we don't know exactly what angle x is, but picture that if I doubled it, it's possible it could take me to the second quadrant, in which, sure enough, my cosine value would be negative. So that might happen from time to time, so just be careful of that a bit. Now, for my last one here, hopefully I'll have enough room here for the tangent one. Again, the formula for tangent you can look on before. I'm just going to go right to that formula to make sure I get everything in here. So 2 times the tangent of theta. If I look at my diagram, the tangent opposite over adjacent is going to be 3 over that square root of 7. That's in my numerator. And my denominator will be 1 minus that tangent squared. So 3 over the square root of 7 squared. So my numerator, I'm going to get 6 over the square root of 7. My denominator, which since I have to square this, if I square that, that's going to be 9/7, I believe, right? 9/7 when I square that. So 1 minus that would be 7/7 minus 9/7, so negative 2/7. So 6 times the square root of 7. I multiply by the reciprocal again, times negative 7 over 2. And I am going to get some weird value like, my 2's are going to be able to cancel out here a bit. So I'll get a 3 there. So I'll get negative 21 over the square root of 7. Now I can rationalize that a little bit, but I'm going to just leave it as that since I'm kind of out of room here. Again, why is that a negative answer? Well, if you double something in the first quadrant, it's going to perhaps take you into a quadrant where you're going to have a negative value, as is this case. So our guess is, again, we don't know specifically what the angle is, but if both cosine and tangent are negative, we must have taken us to the second quadrant there someplace. So a bunch of goofy algebra here, but it's not too bad. It's really just applying a formula, basically. Now we get to the half angle identities. Again, these are strange. These might not be on the back of your trig card, I don't think. So make sure to get these down. Alpha is just an angle. Notice once again we have that plus or minus idea, and the plus or minus idea meaning that your answer could be positive or negative. And with the half angle identities, as we'll see, we're often looking for not half of the angle, but many times really what is that angle doubled. And we'd like this alpha here, that's the angle, we'd like that to be a nice number in many cases. Alright, let's see if we can figure out this particular problem here. The cosine of pi over 8, and it says use a half angle identity to help us figure that out. Alright, let me figure out a decent color here. Now let's think about pi over 8. How many degrees is that? Well, if you take 180 divided by 8, I'll just do this very quickly and see what we get. So 180 divided by 8 is 22.5 degrees. Now there's nothing on my circle chart that's 22.5 degrees, but keep in mind when I do the half angle identities, I'm really looking for an angle that is double this. In other words, this angle right here, this 22.5, is half of a nicer angle. So how this is going to work then, this could be written as the cosine of 45 degrees over 2, right? There's where the double angle comes in. And so now I'm just going to follow my formula that I had before. Plus or minus, we'll deal with that here in a second. 1 plus the cosine. Now keep in mind I don't use the cosine of 22.5, but I use the cosine of this alpha, which is 45. That's a nicer angle for us to work with. All of that over 2. Now right away I can determine if this is going to be plus or minus. My angle is 22.5. That's in the first quadrant. I know for sure if this is cosine that my answer will be positive. So I don't need to worry about that negative sign. In fact, I can even just erase that negative sign now that I've thought about that and determine what it should be. So let's grind this out, see what we can do. So I have the square root of 1 plus, now the cosine of 45, there's going to be that square root of 2 over 2, That's one that you should pretty much memorize, over 2. Now, that's pretty much a good answer, but how do I simplify this? Well, I don't like all those square root signs, and especially I don't like the square roots in the denominator. And so I could really write this something like 2 plus the square root of 2 over 2. All that stuff's going to be in the numerator. Basically, I just multiplied 1 here by 2 over 2, so I could write that equivalently. And my denominator here would be also the square root of 2, because they have to place that square root in both the numerator and denominator. So, I might not get this done in this slide, but we'll see. I could rewrite this as the square root of 2 plus the square root of 2 over the square root of 2. And again, that's just the numerator part, just writing that differently. Now, dividing by the square root of 2, that's like multiplying by 1 over the square root of 2, right? So now when I multiply across, I get square root of 2 plus square root of 2, like that. My denominator, square root of 2 times the square root of 2 is the square root of 4, which is just 2. And that's basically my answer right there. That's the best I'm going to do, I think, is right here. Strange answer, certainly, but shows you how these half-angle identities work. So we'll be practicing on these in class some more, of course. So thanks for watching, everybody, and we'll see you guys then.